the weird link between non-targeted food testing and protecting the Amazon rainforest. What is non-targeted testing? Targeted testing is the process of testing for a specific characteristic of a food or for the presence of a specific adulterant in food. Testing a sample of minced meat for horse DNA is targeted testing because you're looking for the target adulterant, horse meat. Other examples of targeted tests include chemical analytical methods for detecting melamine in milk powder or lead-based textile dyes in spices. Non-targeted tests do not reveal any specific characteristics of a food, and they don't quantify the presence of an adulterant in a test sample. Instead, they can be used to determine whether a food sample is typical of an authentic sample or is atypical. Samples that are atypical could be affected by food fraud, or they could be different from typical due to a benign reason. Non-targeted tests use sophisticated mathematical modelling to statistically compare the analytical fingerprints of hundreds of known samples to the fingerprint of a test sample. Traditional analytical methods such as mass spectrometry, stable isotope ratio analysis, or gas chromatographic methods are used to create the fingerprints. Because each fingerprint contains a lot of information, for example, many peaks on a spectrum, computer modelling processes are used to create a multidimensional model of dozens or hundreds of known samples. When enough samples have been included in a model, it can be used as a comparison for unknown samples. In food fraud testing, the set of samples used to build the model is often referred to as a database. A major advantage of non-targeted testing for food fraud is that you don't need to know what type of food or adulteration you want to test for. This makes non-targeted testing suitable for finding fraud that was unexpected and uncovering new adulterants. Non-targeted testing can also be used to differentiate between populations of authentic samples. For example, agricultural commodities grown in different locations. These population characteristics allow for an unknown test sample to be matched to a known population. For example, in the image shown above, an apple grown in Slovenia in 2016 has a sufficiently different set of stable isotope ratios that it can be differentiated from an apple grown in Austria in 2015. An apple from an unknown origin could be matched to one of those populations by testing it for stable isotopes and applying the same statistical model. Soybeans and the Amazon rainforest. Soybean production has doubled since 2002 and increased tenfold since the 1960s. Much of the increase in production has been possible because of the expansion of croplands into previously uncropped areas, including rainforests. Brazil eclipsed the USA as the world's largest soy producer in 2019. Argentina is the other major producer with 11% of global supply. Brazil has tripled the amount of land it uses to grow soy since 1980, and some of that land has been made available through deforestation. More than 11 million acres of the Amazon rainforest were cleared between 2019 and 2022, and 792,051 square kilometres of rainforest. I'm going to say that number again because it's really big. 792,051 square kilometres of rainforest have been lost since 1970. That's bigger than the area of France. Or for you Americans, that's bigger than Texas. Testing for rainforest in soybeans. Consumers and food manufacturers want to avoid soy that is contributing to deforestation, but recognise that supply chains are complex and the origins of soybeans can be masked by food fraud perpetrators. Researchers from Queen's University Belfast responded to calls from industry who requested a laboratory method that would help identify soy from problematic areas. The researchers are now in the process of developing a commercially available and ISO-accredited technique for determining soybean origin. They chose an elementomics method, an untargeted test method, which makes use of the differences in concentrations of chemical elements between soybeans from different areas. In this technique, 45 elements are measured using inductively coupled plasma. Try that again. Inductively coupled plasma mass spectroscopy. Trying again. Inductively coupled plasma mass spectroscopy, ICP-MS. Two other sophisticated spectroscopic methods, I'm not even going to try and say those, LC-QTOF and GC-MS-MS, were also investigated, but they did not provide as much differentiation between the samples as the ICP-MS method. How to build an untargeted test method. Hundreds of samples from 8 soybean growing countries were collected for testing from contacts in each country. Each sample was tested 10 times, yes, 10 replicates, using ICP-MS to measure how much of each of 45 elements, such as iron, selenium and sulfur, was in each sample. With each test run, a certified reference sample of soy, a CRM, was also tested to confirm that the instrument was performing consistently over the 2 years that it took to perform the tests. The researchers then combined the results using computer-generated statistical models. Different computer modelling processes were used to interpret the results, and the models were compared to see which one was the most capable of accurately identifying soybeans from different regions. The computer models were validated more than 50 times with previously tested samples and new samples of known origins. PCA, and that is predictive discriminant analysis, and OPLSDA, orthogonal projections to latent structures discriminant analysis, were two of the statistical modelling tools tested by the researchers. PCA and OPLSDA are techniques for analysing large data sets with high numbers of dimensions. For the soybean elementomics project, OPLSDA proved to be a better model because it was able to clearly differentiate soybeans from the top 5 producing countries. Thanks to the development of this method, it's now possible to perform a lab test on a soybean sample and find out which country it was grown in. The method has an accuracy of 97.5% when determining the country of origin of soybeans from 8 countries, including Brazil, USA, Argentina, China, and India. Using the test to protect the rainforest. Last month, a new EU regulation on deforestation-free products came into force. Businesses that sell commodities that are high risk for deforestation, including soy, beef, palm oil, cocoa, coffee, and chocolate, are now obliged to show evidence that they are not sourcing products that contributed to recent forest degradation before importing them to EU markets. The rules will be enforced partly by classifying the country of origin as high, standard, or low risk for deforestation. Unfortunately, the new rules could increase food fraud by motivating traders to misrepresent the geographical origin of commodities from high-risk countries. Commodity buyers and traders will be able to use the new test to make sure their soy has genuinely been grown in countries where deforestation is not a major concern, thereby reducing demand for rainforest unfriendly soy. What's next? Right now, it's not possible to distinguish between soy from recently deforested areas and older farming areas of Brazil. However, if enough samples can be obtained from the relevant regions of Brazil, that may be possible too. Soon. The team which developed this technique is planning to make it commercially available, and it will be ISO accredited by UCAS. In short, soy production contributes to deforestation in countries like Brazil. Soy supply chain stakeholders asked Queen's University Belfast Food Fraud Group to develop an analytical method for determining the origin of soybeans. An elementomics method was developed that can identify the origin of soybeans at an accuracy of 97.5%. This method will support soy purchasing companies' efforts to avoid sourcing from areas that have been recently deforested. And as always, there are links to all the sources in the email and the post. And the main source for this post was Dr. Brian Quinn's presentation at the UK Government Chemist Conference in 2023. And you can actually watch a replay of Dr. Quinn's talk and the rest of the talks from the conference online on YouTube. And again, there's a link in the email and in the post. And finally, can you help? If you have access to genuine soybean samples from verified locations, then Dr. Quinn would really, really like to have them. And there is a link to find his contact details again in the email and the post. And by the way, if you haven't not subscribed to the newsletter yet, The Rotten Apple, then please go ahead and click the link in the description and do that now.